Dear students, in the present session, we discuss a concept known as margin of error. What we discuss here is, we discuss how the sample size affects the precision of estimating a population parameter mu using a sample statistic x bar. Now, as we have stated earlier, larger the sample size, smaller will be the sampling error. That is, as the sample size increases, sampling error decreases. Now, as we have studied the concept of confidence intervals, we can determine how exactly the sample size affects the accuracy of the estimate. How exactly the sample size affects the accuracy of the estimates. And we begin our analysis by introducing the concept of margin of error. Now, in the previous class, we have considered an example. That is, the example is the Z interval procedure for the mean age of civilian labor force in US. And we have discussed how to obtain a 95% confidence interval for the mean age mu of all the people in the civilian labor force, where we have specified alpha as equal to 5%, 0.05. So Z alpha by 2 is equal to Z 0.25 is equal to 1.96. N is 50. Sigma is 12.1. X bar is 41.4. Remember this, we will do all these calculations using the softwares. Now, the 95% confidence interval for mu was x bar minus Z alpha by 2 sigma by root n to x bar plus Z alpha by 2 sigma by root n. That is 41.4 minus 1.96, that is sigma 12.1 by root n, root 52, 41.4 plus 1.96, 12.1 by root 50. The value is 38 to 44.8. So the 95% confidence interval for mu of the entire civilian labor force is 44.8 to, that is 38 point, and the mean is 41.4. And what is this distance? This is 3.4. This is also 3.4. And this value is Z alpha by 2 sigma by root n. Z alpha by 2 sigma by root n is 3.4. 3.4. And the interpretation of the confidence interval is, we are sure that the mean age mu of, or we are 95% confident that the mean age mu of the US civilian labor force lie between 38 and 44.8. We are 95% confident about the mean of the civilian labor force. And the width is, actually the sample mean obtained is 41.4, but the width of the confidence interval is 38 to 44.8. It is rather a wide range for the possible values of mu. Now, the precision of the estimate is determined by the quantity E. E is equal to Z alpha by 2 sigma by root. The precision of the estimates is given by E, and E is half of the distance of the confidence interval. In our example, it is 3.4. The width of the confidence interval is 6.8. So half of the width of the confidence interval is E, and this quantity E is known as the margin of error. So what is E? E is Z alpha by 2 into sigma by root n is known as the margin of error, also known as the maximum error of the estimate. The maximum error of the estimate. So we can state confidence interval as equal to point estimate plus or minus margin of error. Confidence interval is equal to point estimate plus or minus margin of error. So this quantity Z alpha by 2 into sigma by root n is known as the margin of error. Now, in this example, the margin of error is 3.4. Now, if you want to improve the precision of the estimate, you have to decrease the margin of error. If the margin of error is very high, very large, the precision of the estimate is very poor. So if you want to improve the precision of the estimate, you have to reduce the margin of error. Now, as you can see, the margin of error is given by the formula, and n is the sample size. And as you can see, n appears in the denominator of the equation for margin of error. One way to reduce margin of error is to increase the sample size for a given confidence level. For a given confidence level, say 95%, 99%, etc., one way to reduce margin of error is to increase the sample size increase. The length of a confidence interval for a population mean mu and the precision with which expert estimates mu is determined by the margin of error E. That is, the length of the confidence interval and the precision with which expert estimates mu depends on the margin of error E. This is E, the margin of error. For a fixed confidence level, say 95%, 90%, etc. Increasing the sample size improve the precision of the estimate as it reduces the margin of error. So margin of error can be controlled through confidence level, sample size. Margin of error E can be controlled by 1. Confidence level, 2. Sample size n, because E depends on Z alpha by 2, that is the confidence level. Z alpha by 2 depends on the confidence level. Sigma is population standard deviation. It is not in our control. Then E depends on the sample size. So E depends on confidence level and n. Now let us see what is the relation between confidence and accuracy. It can be stated as, for a fixed sample size, decreasing the confidence level decreases the margin of error and hence improve the accuracy of confidence interval estimate. So for a fixed sample size, reducing the confidence level reduces the margin of error. Let us see this with an example. That is, n is fixed. If you reduce confidence level, margin of error also decreases and accuracy of confidence interval estimate improves. N is equal to 50, x bar is equal to 41.4, sigma is equal to 12.1, and for a 95% confidence interval, Z alpha by 2 is 1.96. Then E is, and the confidence interval is 38.40 to 44.8. If a 90% confidence interval, Z alpha by 2 is 1.645 from the table. That means the confidence interval is 38.6 to 44.2. 38.6 to 44.2. So, in this example, 38.44.8, we are 95% confident that parameter will lie in this interval. In this case, we are 90% confident that parameter will lie in this interval. So what we say is, if you reduce the confidence interval from 95 to 90, here it was the margin of error in the first example was 3.4. Now in this case, the margin of error has decreased to 2.8 or something. So if you decrease confidence interval, then margin of error also decreases. So margin of error and confidence level are directly related. If you reduce confidence interval, margin of error decreases and vice versa. And what about the sample size? It is clear that as sample size increases, E decreases. E decreases. No need for an example here. So remember this, margin of error is Z alpha by 2 into sigma by 40. Margin of error. It depends on, so margin of error depends on two things. One, confidence level. Two, sample size. Increase the sample size, margin of error decreases. reduce the confidence level, margin of error decreases. Remember these 2 points.